this, I see a lot of interesting solutions, and interesting means wrong, okay, when I walk around there, okay, for ways to do this. So why did this is the thing that's really, really important with this. Okay, why did Calvin multiply everything by 105? What's he trying to do here? This is horribly important to Molly. Yes. Okay, the whole purpose of doing this is to get like integer all the way through. Okay, so it's not just because I like to work with bigger numbers, right? It's because I want them to be integers. So what I'm going to hopefully do now is I'm going to divide 105 by 3 and get a whole number. I'm going to divide 210 by 5 and get a whole number. I'm going to divide 210 by 7 and get a whole number. And then 105 should be a whole number. Yes. Okay. So what I got 105 was just 3 times 5 times 7. Right? Because he multiplies by 3, that'll get rid of this one. Multiplying by 5 will get rid of this one. And multiplying by 7 will get rid of that one. Okay. All right. Megan, it's calculator time for you. What's 105 divided by 3, please? 35. Let's keep going. 210 divided by 5 is? 42. 210 divided by 7? Good. And 105 divided by 1 is 105. Okay. Now, hopefully everyone can see in the class, that is much easier to deal with than this. Okay, if you did this a different way, I didn't show your steps, that's okay. As long as we get the same answer in the end here, okay? But it's very difficult to do it a different way than this. This is far and away the easiest way to do it, if you don't mind me saying so. Who had a question there that I was snubbing? Nobody had a question? Oh, you guys are so polite. All right, Karina. Repeat where you please. How do we solve this? What's the first thing I need to do?
Add 42 to 105.
Okay. So I'm going to say 35x equals 30x plus 105 plus 42. So that's 35x. Desiree, what's the next step, please? Great. Awesome. Very good. So 35x minus 30x is 147. So 5x equals 147. All right, Natalie. Final step is what?
Divide by 5.
Okay. So divide by 5 and divide by 5. So x is 147 over 5. Okay, these are big numbers and they're fractions, and that's okay. I'm going to embarrass. When I was gone, I had to pause them. Embarrass anyway. I have 2 jokes to tell you here. One together. I'm going to deal with subbing into equations, standard form. I'm going to deal with Pythagorean theorem. I'm going to deal with lots of stuff. I'm going to start with standard form. Standard form is ax plus by plus c equals 0, where a is positive and there are no fractions. Okay, the reason you use standard form, there's always only one reason you use standard form, and that's what we're actually going to do today. Okay, you use this so we can graph using intercepts. Okay. Okay, so what you can do, and if you remember back from grade 9, you can find the x-intercept, you can find the y-intercept, connect the dots, there's your graph. Okay, and that's what this equation can very easily help you to do. I asked for volunteers here instead of picking on people. How do you find an x-intercept? Because I don't recall back from grade 9. Aiden, go ahead. Awesome, okay? So I'm going to make it easier than that. It is what you do, like mathematically, okay? But I'm going to just write it as set y equals 0 and solve for x. Now the reason y has to be 0, like on the intercept, right, it's going to be something comma 0 is going to be your point. And y-intercept is going to be the opposite. It's going to be set x equal to 0 and solve for y. All right, intercepts, it's a lot easier to solve some of these equations. I mean, if you're trying to graph with slope, like you know how difficult it is to graph with slope. Like you've seen some of them. If you're graphing something like 2/3 x plus 13 over 4, that's a mess to graph, okay? But if you can get the x-intercept and the y-intercept, connect the dots, it's much, much easier to navigate. So here we go. I did 2 examples on this, then we're going to move on. Example 1, it's going to say, find the x and y-intercepts of 2x minus 3y minus 12 equals 0. Now again, you could put this into y equals mx plus b form if you wanted to, okay? But it would be fractions and all sorts of mean things, right? I'm going to ask for a volunteer to look at the left-hand page and then to tell me how I might find the x-intercept. Bailey, go ahead.
So set y is 0.
Good. So to get my x int, we're going to do, as Bailey said, set y equals 0. So the equation is going to change into 2x minus 3 times 0 minus 12 equals 0. Now take a step back because this is deep. Okay? So what she just did is she just subbed the values in. Remember we did this on table of values probably last week, I don't remember what day it was. Right, you're just subbing values in there. So everywhere she saw a y, she just subbed in a 0. Okay, can I have another brave soul? Bailey, just tell me what negative 3 times 0 is, please.
0.
Good. I'm going to change it to a positive 0. Actually, I'm just going to leave it as a minus 12. If you take a look now, the y's gone from the equation, so we're happy. Okay, we're tremendously happy, in fact. Okay, I'm going to pass on Bailey right now. You can come back to the next question. No, what is your next to solve for x?
12 on the other side.
Good.
12.
So 2x is 12. Can I get a last brave soul? Go ahead, last step, go ahead. Good. So you got x equals 6. Okay, now here's the tricky part that I want to make sure you guys get, because this is x-intercepts are a huge part of grade 10. Not when we get to like straight lines, when we get to parabolas though, which I just showed you this, didn't I? We're dealing with this sort of graphs this year. Did I mention that yet? If I haven't, we do. We get to this graph. We'll be dealing with x-intercepts a ton in this course. What is, if I was graphing this, and I'm not going to graph this today just to save time, but what would the x, y, like the something comma something be for this point? What comma what? Look a little louder.
We haven't found y yet.
Yep.
It's x 0.
Go ahead, Allison.
Y 0.
Y0, right? So our point here is going to be 6, 0. Right? Because that was our first given at the beginning. Our given statement at the front was y equals 0, so we just solved graphs. So there would be one point on my graph I want to graph with.
So they'll give you one of the.
Yeah, in this case, yeah, for sure. Because like when I'm finding the x and the y, you're going to force one of them to be 1, and it's going to solve this. Right? Because basically what I'm doing here, I'll show you what I'm trying to do. Like here's my graph. I'm basically going to say, well, here's my x-intercept there, 6, 0. I'm going to find my y-intercept up here, and then there's my line. It's going to look something like that. Like that's what I'm trying to do there, right? So there's 6 and 0s over there.
So if you want to find y with the same example, then
Yeah, and that's what I'm going to do right here. So I have to find the x and the y. So the y-intercept right here. So other than Bailey, since I know she knows this, how do you, so other than Bailey, Hayden, go. How do you get the y-intercept? Set x equals 0. Good. So that's going to be 2 times 0. Negative 3y minus 12 equals 0. Okay, can someone be brave? Go ahead, Noah.
Negative 3y.
Yeah. Wonderful, because 2 times 0 is 0. Now, you can see what we're doing here. We're just canceling out one variable. Okay, that's what we're trying to do. Can I get someone else that's brave, please? It's the same people always. Go ahead. Good. Negative 3y equals 12. All right, one other brave person. Go ahead.
divide by negative 3.
Wonderful. See how brave you guys are at algebra? This makes me so happy. So y should be negative 4. Now here's the tricky question. And Alistair's not going to share the answer this time. Can I get someone to tell me, please, what the points are to the graph and what comma what? Yeah, go. Very good. X is 0, right? And then y is going to be negative 4. So if I was to graph this, I'm going to do this very roughly. Please don't tell your parents that I actually did this. Okay, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. The point would be something like this. When I'm recording this on that, they'll see that I did this. Okay, that's what the graph would look like. Okay. Is this somewhat familiar from last year at all? Anybody? What's good?
So will 1 always be 0?
Yeah, that's what I mean. To get the intercept, one of them has to be 0, right? So if for this one here, my y was 0, that's where I got that point. For this one, my x was 0, that's where I got that point. Okay, that's how you get the intercepts with the two answers now. Okay, any other questions before I move on? You guys are so polite. Go ahead.
Actually, I might as well make sense.
Okay, when it makes sense, rephrase your question and ask it.
Are all equations going to be looking like the lines we look like this?
No, I'm going to show you example 2. I'm going to give you a slope equation that's messy, and you're going to turn it into standard form. Okay, that'll be example 2. Example 2 says, okay, I want you to put that into standard form. We're not going to graph this or get intercepts or anything like that. We're going to put this into standard form. Okay, because the nice thing with standard form, as mentioned, you can quickly find the intercepts. Okay, so if you look back, now that I'm picking on you, if you go back 2 pages to the top of this note, what are the 2 things that has to be in standard form? What's the equation have to look like in standard form? That's what I need. Oh, no problem. What I'm saying is, what do I need to have happen to make something in standard form?
Oh, A is positive.
A is positive, good, okay. What else? No fractions. And finally, it has to equal 0.
Yes.
All right, those are 3 things. So, now you're not done yet. I don't like fractions, you don't like fractions. Look, how do we get rid of the fractions in this equation? By what? Okay, which is going to be? Sorry to put pressure. So I'm going to multiply every single term by 28 to get rid of the fractions. Because remember, that was one of the 3 things. She said, first of all, the A has to be positive, which we'll get to in a sec. No fractions. We're going to get rid of the fractions right here, and it has to equal 0. We'll deal with equal 0 thing in a minute. Okay, so you guys should be posing this right now. I'm going to ask for a brave volunteer. Oh, this is going to be mean. Look at this. It has to be from you 5 people. Can I get one of you 5 people right here to multiply this by 28 and tell me what we get? No? Oh. Somebody from those 5 people, we could be here all day. I'll write it out. Go ahead, Noah. Yeah, over 7x, good. And this is a monster. This is a monstrous one. That's huge.
Negative 364.
Oh boy. Over 4. Yeah. Okay. Can I get another brave soul to divide negative 56 by 7 for me, please? 8. Negative 8, but yes. So we're going to say 28y equals negative 8x. And here's the messy one. 364 divided by 4. Go ahead. Thank you. Okay, so things are looking good, but not yet great. I have to get the A to be positive when I need it to equal 0. How do you get it to equal 0? Do that. Aiden, go ahead. Yes? That doesn't get equal 0. That's how you get rid of the A, though, right? So either way you can do it. I would probably, to make it equal 0, I'd probably move everything to the left in this case, because then the negative A will turn to positive A, right? And then the negative 91 will turn to positive 91. So I'm going to call that 8x plus 28y plus 91. All right, now this is the time to pepper the questions before we get to Pythagorean theorem. That's coming up next. This should be coming back to you from last year. I know it's been like over a year for some people. Okay, right? But this should like, this is another big part of grade 9 was algebra, right? You can remember any of this? I wish Chris was in this class. Standard form, yeah! You can tell him I said that too. So you did that every day. Every day you would do that, right? Pretty much, or at least once a week. Okay, here we go, quadratic. I'm going to hit pause and I'll do quadratic formula. Actually, give me a second to breathe. I'll hit pause in the video and then I'll do standard.